When creating electrical drawings, especially colored ones, it's important to clearly designate the neutral wire, which is typically white. Because a white line won't show up on white paper, several methods are used to represent it effectively. Firstly, consider using a gray or blue line. Instead of a white line, opt for a gray or blue line to represent the neutral wire. This provides visual distinction without conflicting with standard color codes. Ensure you label the line clearly as neutral or WH in the drawing legend. This helps anyone interpreting the drawing to quickly identify the purpose of the gray or blue line. Secondly, you could use a solid or dashed line. Employ a solid black line for the hot wires and a dashed black line for the white neutral wire. The contrast between solid and dashed lines makes it easy to differentiate between the hot and neutral conductors. Again, label the dashed line as neutral or WH in the drawing legend to reinforce its meaning. Thirdly, think about using a zigzag line. Draw a zigzag black line to represent the white neutral wire. The unique pattern of the zigzag line ensures it won't be mistaken for other types of conductors. As with the other methods, clearly label the zigzag line as neutral or WH in the drawing legend. Fourthly, try using a special symbol. Introduce a specific symbol, such as a diamond or a triangle, to represent the white neutral wire. To further distinguish the symbol, color it gray or blue. Always label the symbol clearly as neutral or WH in the drawing legend. Beyond these specific methods, there are some additional tips that can improve the clarity and accuracy of electrical drawings. Always use clear and concise labeling to avoid confusion. Ambiguous labels can lead to errors during installation or troubleshooting. Use a contrasting color for the line or symbol to make it stand out on the drawing. This enhances visibility and reduces the chance of misinterpretation. Refer to the standards and codes applicable to your project for specific requirements. Compliance with standards like the National Electrical Code, or NEC, ensures safety and consistency. When working with electrical circuits, it's essential to understand the components and their functions. In a typical 120-volt circuit, you'll have a hot wire, a neutral wire, and sometimes a ground wire. The hot wire carries the electrical current from the power source to the load. The neutral wire provides a return path for the current back to the source. The ground wire, when present, provides a safety path for fault currents. Understanding the color codes for these wires is crucial. In North America, the hot wire is typically black, the neutral wire is white, and the ground wire is green or bare. These color codes help electricians quickly identify the wires and connect them properly. Proper grounding is essential for safety. The ground wire provides a low impedance path for fault currents, which helps to trip circuit breakers or ground fault circuit interrupters, or GFCIs, quickly. This prevents electrical shocks and reduces the risk of fire. Circuit breakers and fuses are overcurrent protection devices that protect the circuit from damage caused by excessive current flow. Circuit breakers can be reset after they trip, while fuses must be replaced. Ground fault circuit interrupters, or GFCIs, are special types of circuit breakers that protect against ground faults. They are typically required in areas where there is a risk of water exposure, such as bathrooms and kitchens. When designing an electrical circuit, it's important to consider the load requirements. The load is the amount of electrical power that a circuit will be supplying. This includes lighting, appliances, and other electrical devices. The load is measured in watts, and the circuit must be sized to handle the total load. The wire size must be appropriate for the amount of current that the circuit will be carrying. The National Electrical Code, or NEC, specifies the minimum wire size for different current ratings. Using undersized wires can cause overheating and increase the risk of fire. The circuit breaker or fuse must also be sized appropriately for the wire size and the load. Overcurrent protection devices protect the circuit from damage caused by excessive current flow. Installing electrical circuits should only be done by qualified electricians. Working with electricity can be dangerous, and it's important to follow all safety precautions. This includes turning off the power before working on any electrical components, using insulated tools, and wearing appropriate personal protective equipment, or PPE. When troubleshooting electrical circuits, it's important to use a multimeter to measure voltage, current, and resistance. This can help you identify the source of the problem. Some common electrical problems include short circuits, open circuits, and ground faults. A short circuit occurs when a hot wire comes into contact with a neutral wire or a ground wire. This causes a large amount of current to flow, which can trip the circuit breaker or blow a fuse. An open circuit occurs when there is a break in the circuit, preventing current from flowing. This can be caused by a broken wire or a loose connection. A ground fault occurs when a hot wire comes into contact with a grounded surface. This can cause electrical shocks and can also trip the ground fault circuit interrupter or GFCI. When working with electrical circuits, it's important to follow all applicable codes and standards. The National Electrical Code, or NEC, is the primary standard for electrical installations in the United States. It provides detailed requirements for wiring, grounding, overcurrent protection, and other aspects of electrical safety. Local codes may also apply, so it's important to check with your local building department. Proper planning and design are essential for a safe and reliable electrical system. This includes considering the load requirements, selecting the appropriate wire size and overcurrent protection devices, and following all applicable codes and standards. By following these guidelines, you can ensure that your electrical system is safe and efficient. In addition to the points already discussed, it's important to consider voltage drop in electrical circuits, especially in longer runs. Voltage drop is the decrease in voltage that occurs as electricity flows through a wire. Excessive voltage drop can cause lights to dim, appliances to malfunction, and motors to overheat. The amount of voltage drop depends on the wire size, the current, and the length of the circuit. The National Electrical Code, or NEC, recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. To minimize voltage drop, use larger wires, shorten the circuit length, or reduce the current. Another important consideration is the type of wiring used in electrical circuits. There are several types of wiring, each with its own advantages and disadvantages. Non-metallic sheath cable, or NM cable, is commonly used in residential wiring. It consists of two or more insulated conductors enclosed in a plastic sheath. Armored cable, or AC cable, is similar to NM cable, but it has a metal armor that provides additional protection. Conduit is a metal or plastic tube that is used to protect wires. Conduit is often used in commercial and industrial applications. Each of these wiring methods has specific installation requirements. For example, NM cable must be supported every 4.5 feet and must be protected from physical damage. AC cable must be bonded to ground at each end. Conduit must be properly sized and supported. When working with electrical circuits, it's important to use the right tools. Some essential tools include a multimeter, a wire stripper, a wire cutter, a screwdriver, and the pliers. A multimeter is used to measure voltage, current, and resistance. A wire stripper is used to remove the insulation from wires. A wire cutter is used to cut wires. A screwdriver is used to tighten and loosen screws. A pliers is used to grip and bend wires. It's also important to use personal protective equipment, or PPE, such as safety glasses and insulated gloves. Safety glasses protect your eyes from flying debris. Insulated gloves protect you from electrical shocks. Before working on any electrical circuit, it's important to turn off the power at the circuit breaker. This will prevent electrical shocks. It's also important to test the circuit to make sure that the power is off. You can use a multimeter or a voltage tester to do this. If you are not comfortable working with electricity, it's best to hire a qualified electrician. Working with electricity can be dangerous, and it's important to take all necessary precautions. In summary, designing and installing electrical circuits requires careful planning, attention to detail, and adherence to all applicable codes and standards. By following these guidelines, you can ensure that your electrical system is safe, reliable, and efficient. Regarding the original question about designating a white and neutral wire on colored drawings, all the methods discussed: firstly, using a gray or blue line; secondly, using a solid or dashed line. Thirdly, using a zigzag line. And fourthly, using a special symbol are acceptable as long as they are clearly labeled in the drawing legend. The key is to ensure that the neutral wire is easily distinguishable from the hot wires and the ground wire. And always remember to consult the relevant electrical codes and standards for specific requirements in your jurisdiction. Understanding the National Electrical Code, or NEC, is essential for any electrical work. The NEC is a comprehensive set of guidelines and regulations that cover all aspects of electrical installations. It is updated every 3 years to reflect the latest advancements in technology and safety practices. The NEC covers topics such as wiring methods, grounding, overcurrent protection, and equipment installation. It also includes specific requirements for different types of occupancies such as residential, commercial, and industrial buildings. Some of the key articles in the NEC include Article 210, which covers branch circuits, Article 250, which covers grounding and bonding, Article 300, which covers wiring methods, and Article 400, which covers flexible cords and cables. It is important to be familiar with these articles and any other articles that are relevant to your work. The NEC also includes a number of tables that provide information on wire sizes, conduit fill, and other technical data. These tables are essential for designing and installing electrical systems that meet the code requirements. For example, Table 310.15b16 provides the allowable ampacities of insulated conductors. This table is used to determine the appropriate wire size for a given current rating. Table 310.16 provides ampacities of conductors rated 0 through 2000 volts. The NEC also requires that all electrical work be performed by qualified electricians. Qualified electricians have the training and experience necessary to install electrical systems safely and in accordance with the code. They are also familiar with the latest changes to the NEC and other relevant standards. When hiring an electrician, it is important to check their credentials and make sure that they are licensed and insured. You should also ask for references and check their reputation. In addition to the NEC, there are other standards and codes that may be relevant to electrical work. These include standards from organizations such as the Institute of Electrical and Electronics Engineers, or IEE, the National Fire Protection Association, or NFPA, and Underwriters Laboratories, or UL. These standards cover a wide range of topics, such as electrical safety, equipment performance, and testing methods. It is important to be familiar with these standards and any other standards that are relevant to your work. Continuing education is essential for electricians to stay up to date on the latest changes to the NEC and other relevant standards. There are many opportunities for continuing education, such as courses, seminars, and workshops. By staying up to date on the latest changes, electricians can ensure that they are providing their clients with the safest and most reliable electrical systems possible. When working with electrical systems, safety should always be the top priority. Electrical hazards can cause serious injuries or even death. It is important to follow all safety precautions and to use the right tools and equipment. Before working on any electrical circuit, it is important to turn off the power at the circuit breaker. This will prevent electrical shocks. It is also important to test the circuit to make sure that the power is off. You can use a multimeter or a voltage tester to do this. When working with electrical equipment, it is important to wear personal protective equipment, or PPE, such as safety glasses and insulated gloves. Safety glasses protect your eyes from flying debris. Insulated gloves protect you from electrical shocks. It is also important to be aware of the potential hazards of electricity, such as arc flash and electrocution. Arc flash is a sudden release of electrical energy that can cause serious burns and other injuries. Electrocution is the passage of electrical current through the body, which can be fatal. By following all safety precautions and being aware of the potential hazards, you can minimize the risk of electrical injuries. Remember the principles of electrical safety, including de-energizing circuits before working on them, using appropriate personal protective equipment, and maintaining a safe working distance from energized equipment. These practices are crucial for preventing accidents and ensuring a safe working environment. Furthermore, it's essential to understand the function of various protective devices, such as fuses, circuit breakers, and ground fault circuit interrupters, or GFCIs. These devices are designed to protect against overloads, short circuits, and ground faults, which can cause fires and electrical shocks. Regular inspection and testing of these devices are necessary to ensure their proper functioning. Proper grounding is another critical aspect of electrical safety. Grounding provides a path for fault currents to flow back to the source, allowing protective devices to trip and to energize the circuit. A properly grounded system helps to prevent electrical shocks and reduces the risk of fire. In addition to technical knowledge and safety practices, effective communication is essential in electrical work. Clear and concise communication between electricians, engineers, and other stakeholders helps to ensure that projects are completed safely and efficiently. It's also important to document all electrical work properly, including wiring diagrams, test results, and any modifications made to the system. Accurate documentation is essential for troubleshooting and maintenance purposes. Furthermore, it's important to stay informed about changes in electrical codes and standards. The National Electrical Code, or NEC, is updated every 3 years, and it's essential to be aware of the latest requirements. Continuing education and professional development are crucial for staying up to date in the field of electrical work. By continuously expanding your knowledge and skills, you can provide the highest quality of service to your clients and ensure the safety of yourself and others. Remember that electrical work is a complex and demanding profession that requires a high level of skill, knowledge, and attention to detail. By following the principles of safety, staying informed about codes and standards, and continuously expanding your knowledge and skills, you can excel in this field and contribute to a safer and more efficient electrical infrastructure. When designing an electrical system, consider future needs and plan for expansion. This may involve installing additional conduit or increasing the size of the service panel. By planning for the future, you can avoid costly and disruptive upgrades later on. Choose energy-efficient lighting and appliances to reduce energy consumption and lower utility bills. LED lighting is a great option because it is much more energy efficient than incandescent or fluorescent lighting. Energy Star appliances are also a good choice because they meet strict energy efficiency guidelines. Use occupancy sensors to control lighting in areas that are not frequently used. Occupancy sensors turn the lights off when no one is in the area, which can save energy. Install dimmers to control the brightness of lights. Dimmers allow you to adjust the light level to suit your needs, which can save energy and creates a more comfortable environment. Use timers to control outdoor lighting. Timers turn the lights on and off automatically, which can save energy and improve security. Plant trees and shrubs to shade your home from the sun. Shading can reduce cooling costs in the summer. Insulate your home properly to reduce heating and cooling costs. Proper insulation can help to keep your home comfortable year-round and can save you money on your utility bills. Seal any air leaks around windows, doors, and other openings. Air leaks can allow heat to escape in the winter and cool air to escape in the summer, which can increase your energy bills. Install a programmable thermostat to automatically adjust the temperature in your home. Programmable thermostats can help you to save energy by automatically lowering the temperature when you are away or asleep. Conduct regular energy audits to identify areas where you can save energy. Energy audits can help you to identify areas where your home is wasting energy. There are many resources available to help you save energy. Your local utility company may offer rebates or incentives for energy-efficient upgrades. The U.S. Department of Energy also has a website with information on energy efficiency.